Hello and welcome to another physics problem tutorial with Daniel. So today we are covering problem number 66 in chapter 11, which is talking about angular momentum. So in our question, we have a block that slides down a slope, collides with a rod, and then the rod and block stick together and rotate upwards. So we can separate this problem into three parts. The first part, the block sliding down the slope, we will use conservation of energy. So the second part, the block colliding with this rod, we will use conservation of angular momentum, and when the rod and block rotate upward, that is again conservation of energy. So let's start with the first conservation of energy. This is a relatively simple one. We see initial gravitational potential energy of mgh, and we have a final kinetic energy of half mv squared. So we can see that v is the square root of 2gh, which should look pretty familiar. So our second part is a bit more complicated, which is the conservation of angular momentum. So we have Li equals Lf. We see that Li is the angular momentum in this block, which is equal to mvr here, because there's a 90-degree angle in the collision. We can then set this equal to Lf, which is I omega, which equals a third m rod L squared, because that's the formula for moment of inertia of this rod, and plus mbl squared times omega. So we can solve for omega by doing omega equals mvr over a third mrl squared plus mbl squared. So we plug all our numbers in, including this value for v, and we should get, if you put the numbers in right, that omega is 3 radians per second. So here we move on to our third stage, which is conservation of energy. So here we see that we have initial rotational kinetic energy of half I omega squared, which is still this I and this omega, and then this will equal the final gravitational potential energy of mgh. But what exactly is our h? So here our h should be the height of the center of mass, the change in the height of the center of mass. So first we see that if our block is here, then its mass is concentrated at the end, and the rod's mass, the average center of mass for the rod, should be at the middle. And because the rod is twice as heavy as the block, the center of mass should be a third of the way from the center to the edge, or here. And again, we'll do the same thing with this. So if we solve for h using our known values of I, omega, m, and g, we should get that h is 4 centimeters here. So we can see that the difference between this point and this point is 4 centimeters. So essentially what we see is that we have this is 20, this is 20, this is 20. So this is 1/3 of the way, so this is 20/3. So then this entire distance is 80 over 3. So what we see is that we can express the difference in height between these points as 4 centimeters, but we can also express it as 80 over 3 cosine theta, or 80 over 3 minus 80 over 3 cosine theta. So we can write that out, 80 over 3 minus 80 over 3 cosine theta, which equals 4. So we can then solve for theta. So we get 80 over 3 minus 4 equals 80 over 3 cosine theta. Cosine theta then equals 68 over 3 over 80 over 3, which equals 17 over 20. So we can then see that theta is the inverse cosine of 17 over 20, or this should end up as 32 degrees. All right? Okay, I hope this tutorial helped in splitting up a problem into more manageable parts, especially using the different conservation laws. All right, I hope you enjoyed and learned something. Thank you for watching. Bye.